Hi, I'm Victor, the main organizer of the Full Stack Flutter conference. On this channel we publish the best talks from the conference every week throughout the year, so make sure to subscribe so you don't miss out. I'm also the founder of ServerPod, so if you want to build your backend in Dart, make sure to check that out too. Chima Precious is software engineer at Invitace, an open source enthusiast and the author of the Pharaoh package. In this talk he will talk about Dart on the server. Let's dive in.
Hi everyone, and welcome to my talk where I demonstrate my proof of concept typesafe.orm, how you can use it in your own project, and how it basically looks like, how you can use it to store your Dart objects in your databases. So yeah, the entire problem started when I tried to build a Dart blog application purely in Dart. I wanted to use that purely to build a backend to serve a blog application. And then quickly I ran into the issue where I needed to store data into my database, and I realized that I couldn't find any good ORM that could give me the features I wanted, like migrations and these other things. So I started to write my own proof of concept, which I will demonstrate in this talk. My goals for this library were very simple. I wanted a way to be able to store data for my application in SQLite, Postgres, MySQL, MariaDB, and these other databases. As you can see on my screen here, I have a user class, a basic class in that. And this class has an ID field. It has a username, an email, and then a password. And then it has a primary constructor here. And then it has some functions here, which we can use to serialize our user class. So before we can be able to store an instance of a user into the database, we need to conform this class into some structure that can be compatible with database primitives. So the first things I want to do is to add more details to this class to give it extra context that would help us store an instance of a user in our database. So the way I do that is user class is going to extend entity, and then it's going to take a user here, and then I need to annotate this table. So it basically means that any code generation tool that is going to be passing this piece of code is going to know that, okay, the user class actually represents some table in some database. Okay, I also need a primary key. I can annotate this as an auto-incrementing primary key because I want the database to automatically give a primary key to my entry. And now what do? I need to generate some piece of code. Let's go look into the user.g file and see what we have. Okay, so this is entity generator. We have a user query, which would be using to build our queries. We have a user schema, which would use to run things like migrations. And then we have a user type definition, which is actually something that you would never interact with, but then it helps to make the ORM work. And for relational databases, you need to prepare the database for storage. Like, you need to prepare it for the type of data that you're coming to store. So now that I have a user class, I need to prepare my database to be able to hold an instance of a user, and thereby needing migrations. I want to generate a migration script which would allow me to prepare my database, which in this case is SQLite. And you can see I have this configuration file here, which basically allows me to define the configurations for my ORM. This takes a default connection and then a list of connections, because the ORM allows you to have multiple connections. So at runtime, I can be talking to Postgres at this point, and at another point, I can be talking to MySQL DB or anything. So user table. So I run this. So as you can see, I have a database directory, and inside that I have migrations, and then I have a add users table. This generates purely that code. So I can go into here. We have two functions, or two methods actually. We have the up and then the down. The up would be called when we want to migrate our database, and then the down will be called when we want to reset or revert that migration script. The way I do modify this to create a users table is schemas.add, and then I'm going to add the user schema which was generated for us. And in the down script, I need to do schemas.add schema.drop if exists, and then I pass my user schema here. Okay, so now you can see that I have a migration script written. The ORM comes with a CLI tool, which I can basically run Yaroo ORM, and then I type migrate. So once I type this, it should prepare my databases for storage. We have this log print, which basically says add users table and the status is migrated. When you try to run this again, it should be able to smartly tell you if we get already migrated. Okay, in my bin directory, I would go create let's call this ORM demo.dat, and inside here I would have my main entry points. And you can notice inside this database directory, we have a database.dat file, which is also generated, which has an initialized ORM. So inside here, I'm going to import that database file, and then we do db.initializeORM. So once I do this, I can now have, let's see, user query. Let's make this async, and then we have user query.insert, and I'm going to type new user here. Okay, so you have this convention. If your entity is, let's say, user, to insert a user into the database, the class will be called new user. If you have a post class, to insert a post class into your database, it would be called a new post. So in this case, mine is new user, and you can see that it only requires my username, email, and password. I can provide a username here, code keys, and my email is going to be chima@hello.com, and the password is going to be fullbar123. You can see that we have a user here, and the return type is actually a user. So I can do something like print JSON encoder with indent, and then we are going to call convert, and then we pass the JSON object. So when I run this, we should be able to create a user into the database, and then we should have a JSON print here. So I can run this, and then we call ORM demo, and then we run this. And as you can see, we were able to create a user in the database successfully. Let's perform some queries. Let's try to, add more users, perform some queries to demonstrate how type safe this ORM is. All right, so I want to insert a lot of users. I want to do insert many, and I don't really care about the return type anymore. I can go here, and then we do this at hello.com. Okay, so we are trying to insert all these users into the database. Let's run that and see what we get. Okay, so you can see that that ran without any errors. It means that we actually created. Okay, so let's find all the users in our database. We are going to say all users will be equal to await, and then I want my user query dot find many all users. Actually, let's do JSON. Let's do final users to JSON will be all users dot map, and then we are mapping each element to to JSON, and then make this a list, and then I can print, and I can do convert and users to JSON. Okay, so we should have 4 users printed in our console. So as you can see, we have user 1, which is code keys, and then the remaining users. Now, how do we perform, queries that have certain conditions that need to be met? How do we do this in a type safe way? I can demonstrate that by inside here, we do .where. The ORM allows your queries to be composable. So I go to where user, and then I want the user email to be at hello.com. I should just get a single user because we only have one user with this email. Okay, so as you can see, we only have a single user. Let's say we want to find users where their email is john@hello or their email is chima@hello.com. So how do I do that? I can do and no, that would be an or because this is 2 conditions, either of them. And then I need the first one, which is going to be user.email, and then we're going to have another user.email chima@hello.com. All right, so when I run this, we have the first user being code keys and the second one being, and the ORM also allows you to order this. So I can limit this to just 1, I can order by, and the order bys are also type safe. I can order by a list of things, and I can say order user by their usernames, and the order can be order direction dot descending. All right, so as you can see, we can perform queries in a type safe way. Now let's talk about relations, because in the real world, we have things having relations to something. So in this case, we are going to add a new entity called post. A user is going to have many posts, and then a post is going to belong to a user. So how do we do that? Before that, I need to go model my post in my code base. I can go here and then let's add a post class, post, and then this needs to extend entity, and then we enforce the bounds, and then this is going to be annotated with table, and this is going to have a string ID this time around, and this is going to be our primary key, and then a post has a title, a post also has a description, and then a post has a timestamp. Let me add my constructor. So post, and then post expects an ID. So once I have this, the ORM gives you special annotations like the created at column, and then I have this updated at. Okay. Okay, so once I have this, I need to include my path file, which is going to be post.g.dat. Okay, so let's run our generator to see what we get. This is the post class. We need to have some common property that links, that defines the relationship between a post and then the user. To do that, we're going to introduce another field called, let's say we want to make this a string, and this is going to be user ID. So in order to create a post, we need a post ID, we need a post owner's ID, then we need these properties as well. Once you define this, we are not done. We need to add a special annotation which would allow us to express that relation. So you call that bindings. Bindings are the way we enforce relationships between entities in this library. So once I call add bind to, I can provide a type, and let's run this code and see. Let's run the generator. All right, so you can see that we have some error in our logs here. Let's try fix this together. So you can see I have an error. It says type mismatch between fields, post.userid, which is a string, and user.id, which is an integer. So it means that we need to change this here to an integer because the types are incompatible to establish the relationship. So once I do this, we should be fine now. Amazing. Okay, so that worked. Okay, so if you are familiar with frameworks like Laravel that give you very amazing ORMs like Eloquent, you are pretty much aware of helper functions that allow you to use these relations to fetch data in an efficient way. So the way I can do that is I want to add some helpers to make use of this bindings here. So I can say that a post belongs to user, and then I can make this a getter, and we say the owner. Let's make this user. And then this is going to be belongs to, and then this expects a method name. These method names are very are useful for storing the results of this relation. If it's loaded eagerly, we need this method name, which must be exactly this. And this is due to a limitation in that we don't have very good reflection API. So I mean, a lot of these things are something you have to provide yourself, but if we had very good APIs, then you wouldn't need to provide this. So I can say belongs to, and then I need to provide user here. Okay, so I define this helper, which will be very useful to us. And then I can define the inverse of this, which is going to be a user has many posts. So we're going to say has many, and then a user has many posts. Then we say posts, and then this is going to be has many. And the method name, like I mentioned, is going to be post. And this is going to be post. So as you can see, we just defined helpers that furthermore expresses the relationships that we established. So going over this again, we say a post belongs to a user, and then we express it this way. And then when we go to the user class, we say a user has many posts, and we express it this way. So once we do this, we need to run our generator again. I think at this point, I might just, watch. So build runner is going to uh, automatically watch our code base for changes so that we don't have to be running this every time. Okay, so now that we've added the post class and then we've established all the relationships, what do we need to do next? Like I mentioned, we need to prepare the database to be able to hold a post instance. When we have a post instance and we want to store it, how do we do that? We need to migrate our database. So how do I add a migrations? I can do that run, and then I go to create add post table, and this would create another migrations for me here. So as you can see, I have this. And like I showed you before, we're going to do schemas.add, and we're going to do post schema. And then in the down here, I'm going to do schemas.add schema.drop if exists. And we're going to do post schema. Okay, so once I do this, I can now just run my migration script. I should be able to run my migration script, which would be that run yaroo orm migrate. As you can see, it's migrated successfully. And in order for me to create a post, I need a user that would own this post. So let's say I want to find any user. So any user will be await and user query.find one. And let's say any user is now just return. This won't happen ideally, but just so we please the analyzer, so it knows that we are promoting this type to not be nullable. So once I have this, I can do something like so post will be come on, await, and then we're going to have post query dot insert, and like I mentioned, new post. And then we need to provide an ID, since this is not an auto incrementing ID. So for the ID, I'm just going to put some random string, and let me collapse this. So the title is going to be hello world. Put some special characters inside here, and then welcome to the new revolution. And the user ID is going to be any user dot ID. So we should be able to insert a post. Let's do a post, and let me go make the post JSON serializable so that we can have to JSON. So I'm going to do JSON serializable, and I think that should do. That is all I need. And then I need my let's run the map string dynamic get. No, this would be to JSON, and then we say post to JSON. We pass the instance, and then we do post dot. This should be a factory, and then we say post dot from JSON, and this is going to accept a map string type JSON, and then we're going to do posts from JSON. Amazing. Once we have this, we can be able to call post.toJSON here. All right, so let's run our ORM demo file, and we should be able to create a post in the database. All right, so as you can see, we were able to create a post in the database, and the user ID was 1, and it was created at this date specified here, and it was updated at this date specified here. Okay, so what do we want to do next? Let's say I want to add a couple more posts. Okay, amazing. So this actually works. So now that we have relations, how do we do queries that can take advantage of these relations that we expressed? Okay, so let's say I wanted to fetch all posts where the user email is something. How do I express that? So the way I do that is I can get rid of this and I can say, so post query dot where. Once I call this, I can have a post here, and then I'm going to say post dot owner. I think it's user because as you can see here, this getter is called a user. So this is going to be post dot user dot email. As you can see that it's all type safe. And I'm going to say Chima at hello.com. I'm going to say find many. So as you can see, I am looking for all posts where the owner is chima at hello.com. Let's run this and see what we will get. So this will be posts. All right, so you can see that we have an error here. It says no joins found to enable user.email equal Chima. Did you forget to call with relations? Okay, so even if things break, you get very meaningful error messages that tell you exactly what to do. So I can go here and then I can say with relations, and this is going to be post, and this is going to be a list, and I'm going to say post.user. You see that? So in this single query, I can load relations and perform filters on them. So to go over this again, I say post query dot with relations, and then I specify that I want the user relation to be loaded as well. And then I say dot where post dot user dot email is this, and I say find many. So I think this should work now. Let's see if that works. Let's see if that works. Amazing. So as you can see, we were able to fetch the post, but we're not done yet. So now that we have the posts, how do we get the user that this post belong to? So let's say we want to find one. So this would now be a post. This would be nullable. Since, I mean, we could have instances where this actually doesn't exist in our database, so it's nullable. And then I can do posts dot to JSON. Okay, so I'm going to do something here. I'm going to go into my to JSON, and inside here, I'm going to do this. And then what I want to do is I want to include the user. So I can do something like the user is loaded. Then we want to attach this user, the user dot value dot to JSON. And remember this can be nullable. So when I do this, you see that if we actually eager loaded this, then to JSON would include the user. So let me go into my ORM demo, and then we have to JSON here. So let me run this code again. Actually, you know what? Let's pretty print this so that exactly. So as you can see, we have the post here, we have the user here, and everything here is loaded in a single query. Very efficient, and it's very good for use cases where you're using that on the server side, where you need to talk to an SQLite, you need to talk to Postgres and these other databases. This comes in very handy. And with my existing code, if I needed to deploy this application to production and switch to another database, let's say Postgres, all I need to do is to go into my database configuration here, and then just change my driver to Postgres to PGSQL, and the database is going to take an actual name, and I need to pass a host and a username and these other things, and the code remains the same and it would work. As you can see, it is very easy to use this to write your backend server-side applications. If you're interested in trying this library out, please do check out my GitHub. The project is open source, it's a proof of concept, and if you'd want to support development on this, I am very open to having a chat. Please do reach out to me, and let's shape the future of this library together. Thanks for watching. my talk on this conference thanks to the amazing organizers. I would love to see what projects you build with this typesafe.org. Thanks for watching my talk, and once again, thank you.